Well, today we got to work on the GRADALL again. Apparently she got a little attention the other day and decided she wants some more. The bearings went out of the alternator. Anything else looks to be free. Pretty simple fix, not really a big deal. We'll disconnect the battery. Just a regular old Delco Remy. Self-exciting one wire. So really the only wrong with this is the bearing. I don't know, I know I could go and get a bargain basement China alternator at Summit Racing or something. Well, it's stuck on there. But
do you want a hammer?
I want my brass hammer. I want to see what the bearings are like. You know, if I can still get a number off the bearing, maybe if somebody sells a kit, because I would just put this right back on. I don't know, maybe I put brushes in it too while I got it apart, but we'll see. Boy, that is stuck on there.
The one piece fell right there. The little ring, whatever it is.
So you see that pulley in there. This is like from a truck axle, a wedge. Interesting. Probably from over the pond, you think?
Who knows?
I don't know. That housing may be junk. We may not be able to use it. That bearing might have ground into the housing. You know, back in the day, this is what you did when your alternator went bad. You took it apart, you ordered the pieces, you put it back together, and down the road you went. But, you know, we're a throwaway society. Everybody wants to just go buy something new.
Also, the stuff they make these days, that you pretty much have to throw it away. Because to buy parts, sometimes it costs more than to buy a new one. That's what they want.
Yeah. Sucks. My hammer. One of those days I'll fix it.
Poor woody hammer.
That was my favorite hammer too.
Mm-hmm.
Guess it don't matter, does it?
No, we can fix it sometime in our spare time.
I had a guy leave a comment. He talked about my workbench and how it's not really a workbench, it's a catch-all. And I'm like, yep, sure is. And even though my bench looks like this, I sure get a lot of stuff done at this bench.
Yeah.
My shop may be a wreck, but it doesn't stop me from doing things the way I think they should be done. It just means I don't want to spend the time it takes to clean all this. I'd rather be doing things that need to be done.
Well, I have cleaned it off numerous times. The problem is, some of the stuff, I don't know what it is. And if I put it somewhere else, and you're like, where's such and such? And I'm like, I don't know.
Yeah, usually you're like, I don't even know what that is.
Yeah, so I can only do so much. I can't move all this stuff, because then you can't find it. So, okay.
Felt like the bearings came out too.
I don't know. I was trying to see what it was. It was, I think it's metal pieces.
Yeah, it's gonna be the bearing. Oh, look here. There's the cage of the rollers in there. So we'll take that backing plate out, and that shaft is okay. We might have got lucky. That housing might be okay, because this looks like the bearing. The bearing is much larger than this, so it might be all right. I do my ratchet. Oh, it's in my pocket.
Oh, that's pretty common.
I'll use this one till you find it.
Yeah.
I was kind of expecting this to be press in, but this retaining plate's just as good. Better for me, maybe. Well, I could still, the seal is still there, so that means I might be able to get that. It is a pressed in bearing. Wonder how I can get that out. If I get something underneath there and pull it. Either that or I'll have to do the welding trick. Alright, let me knock this out. I'm gonna get that seal out so I can save it.
Well, he tried tapping it out and it didn't seem to budge, so he's just gonna weld it.
You can explain.
Well, when he welds it, it makes it shrink from the heat, and then he can get it out. Oh, got it. How bad does it look?
Okay. So the case is okay. I'll have to clean off where that outer seal was. Alright. Did you find a number?
Well, I did. I can't tell for sure what it is.
Alright, down inside this case on the brush holder, you'll notice you have this, which is a grounded screw, and then see how these are insulated. So we have to make sure we use the right screw in the right place when we take this apart. I was just going to put bearings in it, but seeing how the whole kit was so reasonable, I figured we might as well just do the whole thing. So we're just going to pull all this out, and this is probably one of the easiest alternators in the world to build. If you don't know, an alternator is actually an AC generator that uses diodes and a rectifier bridge to change DC or AC to DC. We have to get the stator out of here now. It's all done by field wiring, windings, and magnets. So as the magnets, you see these openings in here and these windings, as a magnet turns in here, in between these openings, it creates an electromagnetic field, which creates electricity. Electricity and AC, which AC is a sine wave, which is like up and down like a roller coaster. That goes into the rectifier. Sorry, it comes in from the brushes off the armature, and then it goes through your rectifier bridge and your diodes. So the diodes, what they're doing is when you have that AC current that's going to come down, imagine you have a flat line and your AC current goes above it and below it. Well, DC does this. It's on that line, but it goes up, stays on, turns off, comes up, over, turns on, stays on, turns off. So what you have to do is you have to get your electric to be non-alternating. Alternating means we're going below our baseline, above our baseline. DC is direct, up and over. So So that diode is going to stop that electricity from dropping below. So we have to take all this apart.
So hard to get all your arm movements in there.
Yeah, well, I talk with my hands.
I know.
So we have to take this apart so we can get this stator out of here, because all three of these windings, sets of these windings, come in here. And it's very important to understand when you put this together that these windings cannot touch the back of this, because they'll short out, and they can't touch the armature either. Saying I was not going to change all this, because I was just going to change a bearing because it was charging good, but since the kit is so reasonable, it's probably worth it. The kit comes with new nuts for the stator that bolt it to the rectifier bridge. Now this alternator happens to be a self-exciting, so it doesn't require ignition power to turn on. So it's slightly different. Next thing is we have to separate the stator from the housing, and it's usually stuck.
It looks stuck.
Get in here with like a putty knife or something thin and start working. It's usually filled full of crud and dust. And you can see the cutouts right here. When you put it back in, it's got to go in that same place so that there's room for your bolts. Just work it around here. Out, so we'll have to clean both of these sides up as well as clean up this edge here, and then I'll just disassemble the rest of this. So you can see these are insulated wires, so you got to be careful that they don't short out. All right, what do we got left here? Got my quarters. Get some quarters. We'll get that rectifier out of there. Probably start with that wire in here. And none of this is gorilla tight, by the way. If you're that guy that's got to make everything gorilla tight, you're probably not going to do well with this. Alright. I think the kit comes with new bolts for this. So I pulled the springs out of these brush holders already, and they're about 1/3 gone. There'd normally be springs behind here that would keep tension on this so it could run against the armature. Okay, I'll take this out. Probably gonna need that. And I'm gonna get, well, just gonna take this out. Some of them will have a capacitor in here for radio noise. So the capacitor, think of it as like a big battery storage of noise. It can take a lot of the RFI out and keep your radio. If you ever had one with a bad alternator or something, you hear that buzzing noise in your radio that increases with the RPMs. Got one more. This is our battery terminal to the back. You see it comes through here. I didn't get that one. I believe that's a 7/16. Okay, now you'll see this here. It's insulated from the case. This is your battery, positive battery. You get that rectifier out. You'll see on the back of this rectifier, it's insulated. Tell how that's insulated there. So that isolates a battery positive from the actual case itself. Once that's out, again, the kit comes with new ones. Now we can take the regulator. This is a voltage regulator. Now, since we're using it as a self-exciting, there's no plug here. If it wasn't self-exciting, meaning that it would start charging when the ignition is turned on, This one, as soon as it starts turning, then it excites it and turns it on to start charging. So we're not using ignition power to do that. So we have what's called a shunt plug here. So now I guess we're going to clean this up good. I can't put that back together like that. And the kit comes with a plug if you're going to use it that way. So it's a really nice kit. And we'll get this insulator off here. We might as well get to work cleaning this stuff up, huh? Mm-hmm. Yeah, let's go clean. Press that in just till it's flat. That's it. So we're flush now. Good USA bearing, like that. Alright, so now that the bearing's in and the case is ready to go, this is a kit I got from Summit, 7700A. Now this is not for a self-exciting. This is for your traditional alternator that uses ignition power from your ignition switch to turn it on to excite it. Mine, as soon as the engine starts turning the pulley on the alternator, it starts making electric. So the only difference is in the voltage regulator. So the kit came with the new voltage regulator, but it doesn't have the battery terminal here coming in to basically excite it. So we're going to be reusing this so we can still have the self-exciting feature. If in fact this voltage regulator turns out to be not any good, then we'll go back to the other one. When you have an alternator that uses a self-exciting regulator, you do not use the diode trio in the kit, so because it's unnecessary. So shove this back in here. We'll get this into place first. And you remember I talked about before the insulated screws and uninsulated screws, and they were kind of a big deal. And this is where those come into play. They have to go like this. You can see the way this is kind of chamfered here, and you got the two embosses here, so that's how your brush assembly sits on there. And you'll see that the pin holds the brushes in. There's springs behind there, so we like to push it down like that so it's protruding through there enough to grab it and pull it out when we're ready. So the first thing we have to do is remember which one of these were insulated and which ones were not. So we're going to start with the uninsulated screw, which is this back one. This one right here serves as our ground. So we're going to start with this one. And the next one is insulated, which is this one right here. And then we have a jumper wire that goes to the rectifier bridge. It goes here on the gold one. And that is an insulated screw as well. Get these in. Sometimes it takes a little bit to get it down in there just right. There we go. I'll get these started. I'm not ready to tighten them up yet because we want to position them wires just right. Okay. So the next thing is we need to get our battery terminal into the back of the case. So we're going to use a new insulator for that. You can see it's square drive. It just literally pushes in there. And then our stud goes in, double-ended stud, square drive as well. Right there. Just hold that from the bottom. Now we need to put our rectifier bridge in. The rectifier bridge, you can see, is insulated on the bottom, and they are insulated from the metal as well. This is a heat sink. This part here is to dissipate heat. So I'm going to put that right on top of our post, and there's a notch, you can see right in there. That's going to go right over that little ledge right there. That's your locator. And then we're reusing this. I'm not sure if this is a capacitor for eliminating the whine that sometimes you get from a bad alternator or a bad capacitor, because all it does is take that RFI, radio frequency, whatever. It's noise, basically. It eliminates it. So we want to put these in first before we tighten this down. This side gets this ring terminal right here. It goes to from the battery to the voltage regulator. And I thought this came with a new nut for that. Okay. Once we get everything snugged in place, now we need to tighten this because we won't be able to get to it once the stator is in place. Alright, so now I'm snugging everything up. I thought I was done. There we go. Go ahead and get the 2 screws here tightened up. I like to use this kind of as a nut driver because then you really don't over torque stuff. Just be mindful of that pin that you don't push it back through because it'll let the brushes spring out. So now we're ready for the stator. So we've cleaned this all up real good and made sure it's not shorted anywhere, or we have a suspect spot right there where the coil windings could have been getting hot, which is right where the bearing was, so it may have got a little warm there. We'll have to see if that's going to be okay. Hopefully it will. So you put these down in here, and you have to make sure you're paying attention here where your screws go, and then put it in there as level as you can, and then squeeze on this part to get it to go in. I don't like to put it in until squeeze it till it's lined up nice. There we go. Okay, so then your windings go on the rectifier, and then this, because we're using a self-exciting alternator, this is going to go on this terminal. And the kit comes with new nuts for this. See, that spot on this thing makes me think we may have troubles with this winding, and I may have to replace more than I wanted. But we'll see. Now these will be in 11/32. So this is probably the easiest alternator in the world to rebuild if you do it right. And again, now if you weren't using the self-exciting voltage regulator, these 2 wires wouldn't be here, and you would be using this rectifier bridge, and it would go just like that. It would go on those terminals like that. But we're using self-exciting, so we don't need that. Okay, everything's tight now. That's the last piece of that, so now we're ready to put it on the top. So then I just set it up in the vise so it's easier. And when you're doing this, it's a good idea to mark where your clock position is. I didn't do this on this, and I should have, but I know that it goes this way because I knew my pivot bolt was right where my harness went. So then everything's ready to go, everything's finished in here. So what we have to do is set this down in, and again, look at that, nice and clean, goes together easy. Now we just put our screws in the sides of it. Now screws, I went ahead and cleaned them up. I put never sees on them, just in case I have to visit this alternator again someday. Yeah, this takes more time than just going to the parts store and getting another alternator, but I don't mind doing this at all, as long as it works. There's my 5/16 socket here.
Besides, like you said, a lot of the newer parts aren't made as good.
No, no. I don't know where the rectifier bridge was made or the brush holder, but the bearings were USA, and that makes me happy. These don't need to be gorilla tight here either. What do I usually say? 92-year-old Meemaw tight is good enough.
I guess.
Let's get them all started. We'll snug these up. Now that that's on, the last step we can do is pull that pin out right here, and that's going to let the brushes touch the armature. And you'll listen, you'll hear 2 clicks. There you go. You hear just a wee bit of drag. Okay, next step is we're going to test this. We're going to try and test this before we put it on. Let me get set up. Pull that pin out. Listen for it. There we go. Okay. Feels good. Let me put this away in case I need it again. Now I'll set this up in the vise. We'll see if we can make it work. So we tested it and we had 0 voltage. So since this kit came with the other style of regulator, I removed that and that jumper wire for the field terminals, and I replaced those with the diode trio. And now we got it in here. So now we've converted it to a ignition charge. So right now, if you spin it, it won't charge. We got 12.6 right there. Got nothing. So then we stop, it won't charge again. If you spin it, there's about where our RPMs will really be. Probably something like this.
So weird.
So all we're gonna do is, I'm not gonna order another regulator because that's obviously an issue. I'm just gonna use it like this, and we'll just put a plug on this and put ignition power to it. I'm alright with that. It sucks that, you know, if they had the other kit, which they didn't, which otherwise I would have bought it, but anyways, let's go put it on. So this thing originally had a traditional battery power and ignition power on it, so I may not need to add a diode because we're just putting it back the way it used to be before they replaced this. Go ahead. Hopefully. Now, if this was a truck on the road, I would never use these, but because we're using it around here, it never sees salt. I don't mind using that on this. Otherwise, I would have used heat shrink and solder. Gonna go to the battery. Alright, so we got 4.57 coming to the battery, that's good. And a broken meter, that's even better. Alright, so if there is a diode in this or a light that would come on when it's not charging, then we'd be able to shut this off and it would, you know, turn a key off and the engine wouldn't keep running. Okay, so obviously there's a diode in there. If there wasn't a diode on this battery line, it would be backfeeding the ignition switch. So yeah, we're good. Now all we got to do is make sure that we don't have any dead batteries anymore. So yeah, that's that. Unfortunate, very unfortunate, but it worked out. We had what we needed. We just had to do a little bit different wiring is all. I'm gonna throw a zip tie on this, and then when I'm out sometime, I'll get a pigtail that actually plugs in there instead of using something like this. It's just a heat shrink female connector is what I used just to get down into the terminals down there, but it's working. The old GRADALL will be just fine. When I get one, I'll put it on. If I forget about it, well, I forgot about it, which is probably what will happen until it's a problem again. So I have far too much to work on to be too concerned with that. I gotta get a zip tie in here though. I don't like that wire. Yeah, I'll get some zip ties. God, they're rusted. Of course, I grabbed the only pair that are rusted stuck.
I can get you another pair. Those were kind of outside. They were under a hood and they got rusty, but I sprayed PB Blaster on them, but I guess not enough.
I might need a little more. When you got something on your mind other than what you're doing, it never goes well. Okay, gets that clears out of there just fine. Turn them wires up that way just a bit. Yep, we're good. Okay, all right, that is it for the GRADALL for now. Until I promise we'll give you some more attention soon. We just got to get a few things.
Filter.
Yeah, we got 2 new filters. We got oil filter, fuel filter. No, we put the fuel filters on. We got to change oil. 2 new hydraulic filters. We got an air filter, and we're gonna grease it. And I got some hoses to replace.
You know what? We use the heck out of this thing though, and it rarely ever gives us any trouble.
Don't say that.
Well, I'm serious. It usually don't.
It don't. It's a good machine. It's got some. I need to keep up with a little more because there's a lot of things we got to replace the hoses in this boom. The birds made a nest in there. When they did, it let the hose that runs the tilt assembly come off its pulley, and it got jammed up, pinched, and cut it.
Because they had a bunch of like straw and grass and stuff in there.
And I got another steer cylinder I need to get resealed. We did the other one. CE came over. We did the other one, and because it broke, but we didn't seal this one because it was fine. So I'm gonna have to get on that. You know, it needs to be kept up with just so she stays to be a good machine. You know, it is a good machine. It's very important. How could it not be with the Cummins? You know,
True.
And it had a new motor right before we got it. So, anyways, we got work to do. Get you in the next one.